Hello, I'm Dr. Chris Parker, and today we're talking about running a Mann-Whitney U-test. If you follow our flowchart here, you'll see that a Mann-Whitney U-test is the non-parametric alternative to a independent samples t-test. So, the Mann-Whitney U-test compares the medians of two different groups to determine whether there is a statistically significant difference between these groups. I said it is the non-parametric alternative to a t-test, and you use it instead of a t-test when your sample size is small or your data is interval. So you could say, do men and women score differently in exam results? To get this done, you need to have your participant ID, you need to have your group number, and you need to have at least one variable which you're going to analyze. So let's jump over onto my desktop, calculate this, then we'll return to it and have a look at what we actually get when we look at our results and write them up. So here we are on my desktop. I've got my calculators ready to go. I've got my effect size calculator, and I've got my data, which I'm going to use with independent means. So firstly, let's go and choose the Mann-Whitney U-test from our list. Ignore this stuff and go straight to the calculator. Got my data, and these are independent scores. So copy the first score, paste it into sample 1. Copy the second score, paste it into sample 2. Significance levels can be 0.5 and the two-tailed is here. Before I go any further, I'm going to calculate the scores I need for the rest of this. So the median, because non-parametrics use medians and parametrics use mediums, apart from when I make a type mistake. And the median here equals there we are. We can see that we've got 54 people from the cases. So we've got our mediums ready, we know the number of people, got our test, so click calculate U, and here we are. We can also click calculate details to get more details than our standard test. So our Z-score is minus 5.95, our significance is pretty much 0, and we're definitely below 0.5. So let's go and look at the effect size to see what is happening in this particular test. So I choose my Mann-Whitney. The Z I've got is, let's have a look what the Z is. Let's copy and paste it from here. The Z-score is 5.95. The N is it 54? It is 54. So we've got 0.81 is the R, which is the effect size. We have a large effect size, everything's good, and we can carry on. So that was calculating everything we need to know. Let's go and have a look at this again. So we started by entering website 1 scores into sample 1, website 2 scores into sample 2, selecting a alpha of 0.05, and then going for a two-tailed hypothesis. You'll see that what we need is the median, which we calculate in Excel, number of cases, which again we get from Excel, the U-score, which is down the bottom there, the Z-score down the bottom, and the significance, again, down the bottom. And with just the basic work, you can get a lot of things done. So the way that you'd write this up would be a Mann-Whitney U-test revealed a statistically significant difference in the self-esteem levels of males. So MD, the median was 22.5, the number was 27 people, and females, median was 70, and the N was 27. So in this case, a massive difference in self-esteem between men and women. Women in this case having much higher self-esteem for whatever reason. The U is 19.5, the Z 5.95, and significance is 0. In this case, the effect size was large, so we are really, really happy.